And then this is I'm going to show you the internal architecture of 8085 or and 8086 microprocessor, guys. This is the microprocessor which you are going to be using in this course. Okay, so this is the diagram for that, guys. We've got some registers, we've got the ALU there, guys, and some general purpose registers that we have there, guys. So I'm not going to deal too much or to explain much on this diagram, guys, but it's just for you to see, guys, the internal structure of a microprocessor, guys, as you are doing the architecture, the computer architecture, guys. Okay, so here we are going on the control unit, guys. The control unit generates it generates signals with the microprocessor to carry out the instruction which has been decoded. So generates signals within, okay, generates signals within microprocessor to carry out the instruction which has been decoded. So in reality, causes certain connections between blocks of the microprocessor to be opened or closed, so that data goes where it is required, and so that the ALU operations occur. So it synchronizes the whole system by telling device what to do and when to do it. Just like that, it's like it will be controlling, okay, the components of the computer, guys. Okay, and then arithmetic logic unit, this one is the one which performs the actual numerical and logic operations such as the addition, subtraction, and or. Okay, so use the data from memory and from accumulator to perform arithmetic. Okay, so here the ALU or the arithmetic logic unit will be actually using the data from memory. Okay, it will be cache, it will be RAM, okay, or it will be from the virtual memory. Okay, and also from accumulator. I'm going to talk about the accumulator, guys. That one is a register, so always it stores the result operation in the accumulator. The accumulator is the register that we store the result from the arithmetic logic unit. So we have got what we call registers, guys, in a programming, in a microprocessor, guys. So a register, what a register, guys? A register, guys, is also a memory, guys, a temporal memory that we have, which is so closer to the microprocessor, which will be so closer to the ALU, guys. And this one is the memory which will be used by the ALU or by the microprocessor, guys, where it will be actually where it will be processing the data, guys, or executing the instructions. So in 8085 or 8086 microprocessor, programming module includes 6 registers, 1 accumulator and 1 flag register, is shown in the diagram that we have seen, guys. So in addition, it has 2 16-bit registers, the stack pointer and the program pointer. I'm going to talk about these registers. They are described briefly as follows. We have got the 6 general purpose registers to store 8-bit data, which will be storing storing the 8-bit data, which means we know that computers, they understand the binary language, which is 0 0 0 and 1s. Okay, so a single 0 is a bit. So if it is an 8-bit data, which means it have got a series of zeros and ones, 8, guys, 8. And so these are identified as B, C, D, E, H, and L. These are general purpose registers, and also we can combine them to perform some 16-bit operations. If we need to store a 16-bit data, a 16-bit instruction, guys, so we'll be actually join them, and the combination will be BC and then DEHL. Okay, for a 16-bit operation. So the programmer can use this register to store or copy data into the register by using data copy instructions, because these are general purpose registers, which means you can use them for what you want during your programming, guys. Okay, because we are going to do assembly language also here in this course. Then on the accumulator, so the accumulator, guys, is an 8-bit register that is a part of arithmetic or logic unit, guys. This is the part of our ALU, guys, the accumulator. So this register is used to store 8-bit data and to perform arithmetic and logic logical operations. Okay, so that's when a loop comes into place, guys. So the result of an operation is stored in the accumulator. Okay, so the accumulator is also identified as register A. Accumulator is the register A. Okay, its name is its letter representing the accumulator is what? Is A. So the ALU includes we have got the flags, guys, the flags register. Okay, so the ALU includes 5 flip-flops which are set or reset after an operation according to data conditions of the result in the accumulator and other registers. So guys, you know that the result from the in the accumulator will be the result from the ALU's operations. And so all the operations that will be carried out by the ALU, the result will be in the accumulator. So that result in the accumulator, guys, will be the one also which will be affecting our 5 flag registers. Okay, and these ones we call them flip-flops, and they are set or reset, which means they can only carry one single value, guys, like 0 or 1, guys. If it is 1, I think it will be set, and then 0 it's reset. So they are code 0. We've got the 0, the carry flag, the sign flag, the parity flag, and the auxiliary carry flags, guys, which is the AC. The 0 is Z, the carry is CY, the sign is S, the parity is P. So the most commonly used flags are 0, carry, and sign flags. Those three are the commonly used flags what register. So the microprocessor uses these flags to test the data conditions. Okay, so we will be testing the data conditions in the other registers and in the accumulator. What are these conditions? Let's see. Okay, for program, we've got the programming counter. Okay, we are going to okay, here I didn't explain or what the condition will be tested by the 0 flag, by the carry flag. Okay, the 0 flag will be testing the result in the accumulator, guys. If the result in the accumulator is a 0, then our 0 flag will be 0, and then if the result in the accumulator is not 0, guys, then the 0 flag will be set to 1, and then the carry flag, guys, it's like we already told you that we've got 8-bit, the accumulator is an 8-bit data register, guys. So which means if we have the result which have got more than 8 bits, more than 8 sequence of zeros and ones, guys, the carry flag is going to be set to 1. Why? Because we have got a carry. The result in the accumulator, guys, not the exact value, because we have got a carry. We have got some values that we have discarded, which was not able to be contained in the accumulator. So the carry flag will be set to 1 because we have got a carry. Okay, and then if there is no carry, it will be a 0, and then the sign flag, guys, it will be representing the positive or negative, guys, sign, guys. So if in the result that we get in the accumulator is negative, the sign flag is going to set it to 1, and then it will be 0 if the sign is positive. Then for parity, guys, it will be testing the number of 1 or the number of zeros in the register, guys. So if in the accumulator you've got an odd number of 1, guys, of ones, guys, which means the parity flag is going to set to 1. Else it is, if you have got even numbers of 1, it is going to be a 0, guys. So here on program counter, this 16-bit register deals with the sequencing, the execution of instructions. The program counter, yeah, it will be for the sequencing of instructions. How is it going to do that? So the register is a memory pointer, which means it will be pointing to a memory. But which memory? So memory location of 16-bit addresses, and that is why this is a 16-bit register. So the program counter, first to know, is a 16-bit register, and it will store the address. Which address? So the microprocessor uses this register to sequence the execution of the instructions. How? So the function of the program count is to point to the memory address from which the next byte is to be fetched. Okay, so it will be pointing to the next byte, okay, or to the next memory location where you want to fetch the instruction. Why? Because it's like we want our processor to be kept busy actually processing the instructions. Okay, so you don't need it to wait for some components to go and fetch some instructions, but this one will be actually holding the address of the next, okay, of the next instruction to be executed, so that when the instruction, um, the data being processed by the processor is actually accomplished, then it will be actually going to fetch the data from the address on the what, on the program counter. Then it will be easy rather than to calculate the address while the processor is doing nothing, is idle, guys. Okay, so I think that's all. Then on the stack pointer, guys, the stack pointer is also a 16-bit register used as a memory pointer. This one will be pointing to a memory. It points to a memory location for read or write, just a read or write memory called the stack, guys. So the beginning of the stack is defined by loading 16-bit address. This one don't need to. So the stack concept is explained in the chapter stack and subroutines, guys, and we are going to explain it when we get there. So we have got the instruction register or instruction decoder, the temporary store for the current instruction. This one we will be storing the current instruction of a program, which is the instruction being decoded. Okay, so latest instruction sent here from memory prior to execution. Okay, the instruction being decoded or being executed. So decoder then takes instruction and decodes or interprets the instruction from what, from the instruction register. So decode the instruction, then passed it to the next stage, and then we have got the memory address register. So holds addresses, because it is memory address register, it holds addresses and it received this address from PC of next program instruction. So the next program to be executed, okay, that address of that program will be in the memory address register. So feed the address bus with addresses of location of the program under execution. Okay, I think it is clear. For general purpose register, I think I've already actually explained about this. So microprocessor requires microprocessor requires extra registers for versatility for you as a programmer to do what you want. So can be used to store additional data during a program. Okay, so more complex processors may have a variety of differently named registers. So 8085 system bus, we've got the system bus. So typical system use a number of buses, collection of wires which transit binary numbers 1 bit per wire. You know that, guys. You can say my Windows machine is a 62-bit, is a 64-bit, is a 32-bit. Why? Those are system buses, guys. If it is a 32-bit, which means its system, guys, can operate on a bus with the system bus with the 16 wires or with the 32 wires. Okay, if it is a 64, it will be a 64, which means on a single precision it can only actually transmit 64 instructions at a time. Okay, so a typical microprocessor communicates with the memory and other devices using 3 buses, which is the address bus, the data bus, and the control bus. Okay, those 3 ones. The address bus, it will be carrying the address inside of a memory. Okay, and then the data bus will be carrying the actual data, and then the control bus, it will be carrying the signal, which will be actually showing the component which is going to receive the data and the address what to do with that data. Okay, like, is it a write operation? Do we have to save or to store that data, or do we have to read the data from that address? Or that's the computer, that's how it works. Then the address bus, so 1 wire for each bit, therefore 16 bits or 16 wires. You see, guys, for an address bus, if you want to transmit an address with the 16 bits, which means a sequence of zeros and ones, 16. Okay, so it must have a 16 what? 16 wires. Else, you have to do it have to be done multiple times, guys. So binary number kept allows memory to open the designated box. So data binary can be data, or binary can be then be put in or taken out. So the address bus consists of 16 wires, therefore 16 bits. Its width is 16 bits, okay, or its wideness. Okay, and then A 16-bit binary number allows the 2 to the power 16 different numbers. Okay, this one let's leave it because memory consists of boxes. This one let's leave this one also. We are going to do it later. So data bus, guys, a data bus carries data in a binary form, okay, and then which means it will be a zeros and ones between the microprocessor and the other external units such as memory, okay. So the data bus will be actually carrying the data from the microprocessor to other various components like memory, or it will be from memory then to microprocessor. That's how data bus came into place, okay. And then here the typical size is 8 or 16 bits, guys. This is per 8085 or 8086 microprocessor. This is an Intel processor, okay. So size is determined by size of boxes in memory and microprocessor. Size helps determine performance of the microprocessor, okay. So the data bus typically consists of 8 wires because it is an 8-bit, okay. So data bus used to transmit data, that is information, results of arithmetic etc between memory and the microprocessor. And also data bus is bidirectional, which means it can take data from memory to microprocessor, or from microprocessor to memory, or from other components to the processor, and then from the processor to other components. And then control bus. Last, the control bus, guys, are various lines which have got specific functions for coordinating and controlling microprocessor operation. This one will be sending the signal, guys, to control the operations of the microprocessor. So e.g. for a read, which will be a not write line, okay. So single binary digit control where the memory is being written to, which is data is being stored in memory, or read from, which is data is taken out from memory. That's where the control bus came into place. Like we've got the data bus, guys, and then the address bus. So and then the control bus, they will be working in three like this, okay. So the data bus will be carrying the data, the address will be carrying the address, like if it is a write operation, okay, which means we will be having the address where we want to go and save that or and store that data. And then we have got the data, and then we have got the signal which is going to show that component that you have to save this data, okay. So that's where the control bus came into place. So cannot function correctly without these vital control signals. What may also include the clock line, or okay, for timing or synchronizing interrupts, reset. We are going to talk about this later, okay. So I have to say thank you guys for watching this video, guys. This is the introduction to computer architecture. If you like this video, guys, click the like button, guys, and also don't forget to subscribe to this channel, guys. And also put a comment, guys, in the comment section. Also, guys, write anything that you want me to do for you, that you want me to actually do for you in the next videos, guys. So I have to say thank you, guys.